Good morning. My topic is XML Retrieval. First, we will see what is XML. XML stands for Extensible Markup Language. This is not a programming language. It is a data description language. This is used to store and transport data. This is used to specify the logical structure of documents. This is understood both by humans and machines. The main importance of XML is metadata, that is, data about data. An example of XML is an article. Now we will see what is XML syntax. Here, consider a very simple XML syntax. I have created an element called friend list, and here is the end tag of friend list. Then I have created an element friend, its starting tag and ending tag. Then I have created an element name, and the name is Alex. Then I have created an element age, and the age is 25. This is a valid XML document. Now we will see what is meant by root. Every XML document must have a root element, and this root element is the parent for all the elements. In this XML document that I have created here, friend list is the root element for this XML document. Now XML prologue is optional. In XML we can have first line as XML prologue, and as said before, it is optional. Then now we have tags. All the element must have a starting and closing tag. If we see here, all elements have starting and closing tags, and these tags or elements are case sensitive. So if you change the case, that will become a different tag. XML prologue have no closing tag because it is not a part of message. Talking about attributes, if you have attributes in your XML, for example, here I have created an attribute gender equal to male for this for the friend, which is quoted. So this quoted text is called attribute. In XML, the elements must be nested properly. Basics of XML are elements and attributes. Here we have an XML document tree corresponding to this XML document. Now XML validation. When we talk about validation, we are validating the syntax and the structure of our XML message. That is, we check that the XML is well formatted, that satisfy all the basic syntax condition. Then we can also check our XML against some predefined schema, which can be a DTD, that is document type definition, or can be XSD, called XML schema definition. In most of the cases, the creator or developer will provide you the schema, and you will have to check your XML against this schema. It will contain the structure of the XML, how it should be structured, what should be the text, and what is mandatory, what is not mandatory, etc. Now XML DOM. DOM represent the content of XML document as a tree structure. Using DOM, we can easily read, access and update the content of the document because DOM converts XML into a tree structure, and using the programming language which we are using, we can then access and update the contents. Then comes XPath. Suppose we want to extract any value from a node. For doing this, we need some query language that we can use to pass through that XML document and give us the required value. That query language is XPath. Consider this XML document. Here, to extract the value J.K. Rowling from this XML document, we should write a query. Here, slash bookstore refers to this particular node which the arrow points to. To go further again, slash book is added, that is slash bookstore slash book. Now this XPath can refer to both elements named book. Here there are two child elements named book. So we should define which book element we want to access. So we should give the position, that is second book element. Now slash bookstore slash book square bracket 2 slash author will give the value that we want to extract, that is J.K. Rowling. Now what we have just created is called absolute XPath, which means it starts from the root element, like we have the bookstore as the root element, and step by step goes to the element that we want to extract. The example we have seen here is simple, but in real life it will be complicated with so much of nestings. Therefore, we use relative XPath. This start with a double forward slash. Also, some while characters can be used. One of the while character is star, which means it can match anything. To extract value J.K. Rowling using relative XPath, the query which is shown below can be used. Here we can see some XPaths. The first one is act/scene, which selects all the scene elements whose parent is act. The second one is play/scene, which selects all the scene elements occurring in a play element. The difference between these two are, in the first case, only those scene elements are selected whose parent is act, but in the second one, all the scene elements are selected occurring in a play element. Now, if we look at the last one, title #Macbeth, that will select all the titles containing term Macbeth. Now we will move into challenges in XML retrieval. The first challenge in structured retrieval is that users want us to return parts of document, that is XML elements, not entire document, as IR system usually do in unstructured retrieval. Structured document retrieval principle is one of the criteria for selecting most appropriate part of a document. A system should always retrieve the most specific part of a document answering the query. It is hard to implement this principle algorithmically. Second challenge is document paths to index. In structured retrieval, there are different approaches for defining the indexing unit. One of them is indexing all the elements. This is the least restrictive method. This is also problematic because many XML elements are not meaningful search results. Also, indexing all the elements means that search results will be highly redundant, and this is not user friendly to return redundant nested elements. Another approach is to group nodes into non-overlapping pseudo documents as shown in this figure. Its disadvantage is that those pseudo documents may not make sense to the user. Next challenge is related to nested elements. Here the challenge is that We may need to distinguish different context of a term when we compute term statistics for ranking. Another challenge is schema heterogeneity or schema diversity. This is a phenomena in which several different XML schema occur in a collection, since the XML documents in an IR application often come from more than one source. Here in this figure, we can see comparable elements may have different names, like creator in D2 and author in D3. Now we will move into vector space model. Vector space model for XML retrieval. Vector space model basically do is represent everything in a vector in some high dimensional space. In XML retrieval, first we will take each leaf node. Leaf node means a text and break it into multiple nodes. For example, here in this figure we can see we have splitted Bill Gates into Bill and Gates. Then we should define the dimension of the vector space to be lexicalized subtrees of documents. These are subtrees that contain at least one vocabulary term. This figure shows a mapping of XML documents to a set of lexicalized subtrees. These are the lexicalized subtrees, and this is an XML document tree. Now, to compute matches between queries and documents, we should represent queries and documents as vectors in this space of lexicalized subtrees. If we create a separate dimension for each lexicalized subtree, then the dimensionality of the subspace of the space becomes too large. So, we will have to index all paths that end in a single vocabulary term. These are called structural terms. They are denoted like this, that is a pair of XML context C and vocabulary term T. Here in this figure we have 9 structural terms, but only 7 are shown. The seven structural terms shown are these, and the tree with Bill and Gates is not a structural term, that is this last one is not a structural term, but it is a lexicalated subtree. And the two which are not shown are book / author #Bill and /book / author #Gates. So this is all about XML retrieval. Thank you.